Today in class we talked about a different type of naming system called covalent. We do different things with covalent. Remember, covalent is when nonmetals are sharing their electrons. This is on the same PowerPoint, so if you are downloading the PowerPoint, it's the same PowerPoint on chemical bonding. We are just moving on down to Roman numeral 7, which we've done all these others. We're on the 11th slide, which is naming covalent compounds. Again, a covalent is when two or more nonmetals are sharing their electrons. We're going to just do the very basic ones, which are called binary. Bi means two, so two elements are sharing their electrons. They're both nonmetals. That's really key that you see that they're both nonmetals. And the way we name them, we're going to be using prefixes. And prefixes are going to tell how many we have of each element. We're still going to change the ending of the second element to IDE. You're not going to use the prefix mono on the first element, so you might want to underline that. It's the first element. We will use mono on second element, but not on the first element. You'll still use the other prefixes with the first element, such as di or tri, just not mono. I don't know why that is. It's just one of those things that we're not going to use. Our prefixes are mono for 1, di for 2, tri for 3, tetra for 4, penta for 5, hexa for 6, hepta for 7, octa for 8, nona for 9, and deca for 10. Most of you are kind of familiar with these words, like a pentagon and a hexagon, an octopus, a decade. So you've seen these prefixes before. Ones that students tend to have most trouble with are number 4, which is tetra, and 7, which is hepta. Tetra, if you think of the game Tetris, it has 4 sides to it. So if you've ever played that game, that's why it's called Tetris, in case you didn't know. So these are our prefixes. Again, if you're going too fast, you can always pause this, write this stuff down, print off the PowerPoint, whatever you need to do. So we've got some examples. We've got H2O, which we know is water, but it actually has a scientific name. NH3, which is actually known as ammonia, but it has a scientific name as well. And we know we're going to use this because this is a nonmetal and this is a nonmetal. Two nonmetals are covalent, so we would say this is di for the 2 hydrogens, and we just say hydrogen, dihydrogen. Notice I didn't change his ending. And then it's mono is our prefixes for 1, but we've got oxide, so rather than run the 2 O's together, we always drop the first O out of there. So anytime we're dealing with oxygen, the A will drop out or the O will drop out. So this is monoxide. Dihydrogen monoxide, that's the scientific name for water. So you can tell your mom or dad, I would like some dihydrogen monoxide, please. And they might not know what you're talking about, but they're just asking for water. And then this one, we've got nitrogen. We're not going to say mono because that's the first element. Notice I did say di for the first element, but just not mono, so we just say nitrogen. And then we've got 3 hydrogens, so we're going to use the prefix tri. And then it's hydrogen, so we hi, and then we change the ending to IDE. So the endings will be IDE on all of these particular compounds. So not very hard at all. So when you go to write the formula, you just write exactly what it says. It says diphosphorus, so it's P2. It says pent, the A fell out because A went with the O, and pentoxide would be O5. So P2O5. And then carbon tetrachloride would be C. And then tetra is 4, be Cl4. Notice I just wrote what it says. I didn't swap them. I did drop them, but I didn't swap them. And I wouldn't actually reduce them. So if they were reducible, I wouldn't reduce on covalent bonds either. So I'm just writing exactly what it said. So covalents are very, very easy. So there's a worksheet that has front and back for covalent bonds. If you're absent and you're watching this video for You Won't Get Behind, I've actually uploaded those worksheets so you can print them out at home and do them. Or if you're watching this because you fell asleep in class, whatever, or if you've lost your worksheet, you can also download those worksheets. So this is covalent. We also went over something called hydrocarbons. Hydrocarbon is a very special type of covalent bond. It's really getting into something called organic chemistry, which is based on the carbon atom. hydrocarbons always have two elements the same. What they always have in common is they always begin with carbon and they always end with hydrogen. That's what a hydrocarbon is. I don't know why hydrogen said first, but it just is, and it's always carbon first, hydrogen second. And when we go to name them, you're going to count how many carbon atoms you have. We're going to use a little bit different prefixes, and then we're going to add the ending "ane" to the prefix. So these are only going to have like one word with them, like methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. So you may have heard of some of those, maybe not so much with some. Here's an example. Methane actually is CH4 because it only has one carbon. But if I gave you like CH818, you would tell me, because this is 8 carbons, which is the only thing you're going to look at, that this is actually octane. So very, very simple. This one's methane. If you'll notice something here, number 5, 6, 7, 8, 9, 10, prefixes are the same as the covalent. That's why we're learning them on the same day. So the only ones that are different are the first 4. Meth, eth, prop, and bute. Okay, that's 1, 2, 3, 4. So then, what if I said, write me the formula for decane? So, you know it has carbon and hydrogen. You know that it has 10 carbons. So there must be a way to figure out how many hydrogens there are. And that leads us to the next slide. That is a picture of a methane gas on a Bunsen burner, which is the gas that's in the Bunsen burners. This is the way we write the formula for hydrocarbons. In order to figure out how many carbons there are, you're looking at the prefix. In order to figure out how many hydrogens you are, you take your number of carbon atoms times 2 and you add 2 to that. So it's times 2 plus 2. So methane, ethane, propane, and butane. I just did the first 4. So they all contain CH. All of them have CH. The prefix tells us how many carbons. So this one has 1, this one has 2, this one has 3, and this one has 4. Simple as that. 1, 2, 3, 4. I just went in order. Okay? Now to figure out the number of hydrogens, you take this number, which is your number of carbons, you multiply by 2, and you add 2, such as 1 times 2 is 2, plus 2 is 4. So methane is CH4. Ethane times 2 is 2, plus 2 would be 6. Propane, 3 times 2 is 6, plus 2 is 8. Butane times 2 is 8, 8 plus 2 is 10. So hopefully you can see every time you go up by a carbon, you're going up by 2 hydrogens. So there's our formula for butane, C4H10. So what if you had like decane? Well, that's going to be C10, because dec is 10, times 2 would be 20, plus 2 would be 22. So C10H22 is decane. So those are very, very easy to do, and your second worksheet, it does not have a backside to it, is working on hydrocarbons. The covalent one had a backside, so it's front and back, and the hydrocarbon one doesn't. So these are plain old hydrocarbons. Then there's a special type of hydrocarbon called an alcohol. An alcohol is written with a name as anol. They all look like anol. They look just like that. Methanol, heptanol, propanol, pentanol. If you'll notice, they still have the same prefixes as the other hydrocarbons. They have the basic CH part to them, so we could start all these as CH. But the difference, because it's an alcohol, this would be C1, this one is C7, this is C3, and pent is 5. In order to figure out the alcohol, it is times 2, which is 2, plus 1, which is 3, and add an OH. That's what makes it an alcohol. So all alcohols have this basic CHO formula, CH and then an OH. So this would be 7 times 2, which is 14, plus 1 would be 15, then add an OH. This would be times 2, which is 6, add 1, which is 7, then add an OH. This would be times 2, which would be 10, add 1, which makes 11, and then add OH. So you're going to be able to tell the alcohols because they're going to always start with C and end with OH. So they're always a CHOH formula. Now, if we had like MgOH2, that's not an alcohol. This is magnesium hydroxide. This was an ionic compound. The difference being, this is a metal and a poly. So it's not an alcohol. These are all non-metal, 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 non-metal. So this is a special naming. This is an organic compound. So methanol, heptanol, propanol, pentanol. And so you add an all to their endings. And again, they're just one word. So this should be really easy. There are 2 worksheets. The first worksheet, covalent, has a front and back. The second worksheet is over hydrocarbons. It's just front. I have uploaded them as well, so if you're sitting at home and you do not have these worksheets, you could print those out. Have a wonderful day.